Hello everyone. This video, I'm going to show you the example in the textbook. It's also a center of mass problem. Okay, it's a continuous system. And suppose we have a triangle here is on the graph. Okay, a triangle. And the triangle, okay, its length is L, width is W. And the triangle, the mass is m, and we assume this triangle is the density of this triangle is uniform. Actually, it's a 2D problem, so actually the density means the area density. Area density is uniform, and he want to ask you the problem want to calculate what the center of mass of this triangle. Okay, and let's see. Okay. Okay. And this is a 2D problem. This problem didn't ask you to calculate the center of mass, the center of mass, the y coordinate of the center of mass, and because this triangle is symmetry. This triangle is symmetry with respect to the x-axis. So the center of mass in y direction, the y coordinate of the y coordinate of the center of mass must be 0. Okay, because this triangle is symmetry with respect to the x-axis. So COM, YCOM is 0. So this problem didn't ask you calculate the YCOM because YCOM is 0. Okay, YCOM is 0. Okay, but XCOM, the center of mass of or x coordinate of the center of mass of this triangle is not at 0. Okay, so we have to calculate. And the formula to calculate center of mass, okay, do you remember that? Okay, let me write down the formula. The formula is XCOM is the total mass, and is X delta M. Okay. And for this problem, in previous two examples, I said that for this kind of calculation, you must to deal with this dm delta m small delta m. You have to find a relationship between delta m and x or dx. You have to replace the dm with to dx. Okay, or this because right now the xdm this is not integratable. Okay, so you have to find a relationship between dm and dx, and then replace dm by blah 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 dx, and then you can do the integration. Okay, so how to calculate dm? Okay, since it's 2D problem, so it's a little more complicated. Okay, I just make a slice in the same as the previous problem. I make a small slice on this triangle, and the small slice is here. Okay, the very small slice here, but maybe not really that small. Okay, and this area I call it dA. Okay. Okay, this is well, not dA, dm. Okay, this is dm. dm. Okay, and the mass of this the mass of this small slice dm is equal to area density times the tiny area of this rectangular. Okay, dA is the small area of this small area of this rectangular. Okay, let me see, area of the small rectangular. I'm not sure my English is right. Okay, small area of this small thing rectangular. And what's the area of this small rectangular? Okay, so let's say this is called delta x, And this is okay. What is this? Very interesting. This is 2y. Okay, let's see. This is 2y. Okay, because this is 2. I think it's 2y. Okay, so let me see. Okay, I think it's 2y times delta x. So dA is equal to 2y times delta x. So dm is equal to area density times the dA, and dA is 2y times delta x. 2y times delta x. Because this is y. Let me see. This is y. Okay, this is y. This the height is y. So here is y. So the other half is also y. Okay, that is because that is 2y. Okay. And what's the area density of this problem? Okay, the area density, because I say this in this problem, is uniform density. So the area density, what is the area density? Area density is equal to the total mass, capital M, divided by total area. Total area. Okay, what's the area of this triangle? It gives you the width and L. So how to calculate area? I hope you notice the total area is W times L divided by 2. Okay, that's the area density. W times L. So that's area density. Okay, so I think we almost finished everything. Okay, so let's just write it down. Okay, XCON is 1 over capital M integration. Okay, so and let's right now I'm not sure the range. So X and dm is area density times 2y times dx. So it's okay, area density is 2m divided by w times l and times 2y dx. That's dm. Okay, so the capital M, total mass, the width, and L is a constant, is given, so we can factor them out. So it's W times L, 2M. And let me see, should I put this 2? Okay, 2, okay. Integrate x, y, dx. Okay, so right now we face a problem here. Okay, we change the dm with the dx, but the problem, we have something else come out. It's called y. Okay, right now xy dx, right now it's still not integratable. We need to find y. We need to find y is, can we replace y with function of x? Okay, we have to replace y by x. So we need to find a relationship between the y and x. And what's the relationship between the y and x? From this graph, can you find an equation? Sorry, can you find a relationship between y and x? How to find this? Okay. So let's look at this graph. Okay, let's suppose this origin is here. Origin is, and can we find a relation between the y and x? Okay, y is a function of x. So that means, could we find the equation? Can we find the equation of this line? This one. Can we find the equation of this line? This purple line? Okay, this, because the equation of this line give you the relationship between y and x, because y is changing with x, right? Y is a function of x. When x changes, y coordinate also change. So this line will give you the relationship between the y and x. Okay, so can you find the equation of this line? Okay, I think I believe you can do it. Okay, because we have the 1.00 here is origin, and this point here, what's the coordinate? It's L, right? L and W over 2. So if you have 2 points, you can find a line equation of the line, right? Okay, I believe it's very basic high school mathematics. So start from very beginning. Let's assume this equation y is equal to mx plus b. Okay, that's the high school mathematics. And we have 2 points, right? So we have 0 equal to 0 m plus b. And w over 2 equal to m times L plus b. So this is a system of first order equation. And this give you the first equation give you the b is equal to 0. So it's b is 0. So what's the m? M is equal to 2l. M is equal to 2l w over 2l. So we'll finally find a relation y is equal to w over 2lx. So we find the relationship between a y and x. So we have to replace this with the here. And then we will find everything is x, and we're doing integration at x. Okay, we will finally solve the problem. Okay, so let's do it. So XCOM and 1 over m, and this is 4m w dot l times l, and integration range is here is 0. Here x is 0 to l, 0 to l, 0 to l. So it's 0 to l, and x times w over 2l x dx. Yeah, we also have another constant w over 2l, so it's constant. So factor it out. So many constant. Oh, it's crazy. So did I do the calculation right? 2l w equation 0l x squared dx. Okay, so this is also a power function integration. I hope you can do it by yourself. And it's very easy. So let me factor out this cancel this 2. So this will become L squared, 2 over L squared. And this integration is 3L3 minus 303. So L squared times 3L3. So it's cancel out. So the center of mass, the x-coordinate of the center of mass is 2 over 3 times L. So it's probably, it's right about, about center of mass is right about maybe here. Okay, 2 over 3 L. Because this shape, okay, you have more mass. You have more mass at the right hand side, right? You have, because this triangle, you have more mass. Your mass is more distribution near the right hand side. So your center of mass must be at the right hand side of the central. Okay, so it must be over L over 2. Okay, it must be over L over 2. So the answer is 2 over 3L. So it's just the right hand side of the right hand side of 2 L over 2. Okay, so this is reasonable. The answer is reasonable because your more mass is distribution at the right hand side. So it's the center of mass never be at the center. Okay, so 2 over 3 L is the reasonable answer. Okay, and it's really a true answer. Okay, so in this problem, center of mass problem, once again, you have to dealing with the dm or small delta m. Okay, find the relationship between the delta m and delta x. Okay, so delta m is equal to area density times the delta A. Okay, because right now we are two-dimensional problem. So this is tiny areas called delta A, the shade green area. dm is area density times delta A. And what is delta A? Okay, it's with delta x and times the 2y. Okay, because here is y and then you have double it. Okay, that's 2y. Okay, and 2y times times dx, and area density, because I assume it's a uniform distribution, so it's total m divided the area of this triangle. Okay, and we'll get this equation, but we have something else comes out. The y comes out. Okay, we have to replace the y with we have to find a relationship between the y and x and replace y by x. Okay, because or you cannot do this integration. Okay, you have to replace y with x, or this integration is not doable. Okay, and after we find a relationship, okay, you put everything in there, and it's a very simple integration of power function. Okay, so you have to familiar with this type of calculation because this will be used a lot in most, I think, in physics area this semester, next semester, this technique is keep using it, is keep using, or maybe some engineering, yeah, topic. Yeah, this technique is often used. Okay, and I believe your calculus class also demonstrated some example like this. Okay. Okay, so I just start the video here and hopefully you can understand this problem on calculation. Okay, I'll stop the video here. See you in the next video. Bye bye. Ooh.